In this video, we're going to continue talking about reactions, specifically organic chemistry reactions, and this is going to be the last few concepts of chapter 5. When it comes to reactions in organic chemistry, in addition to oxidation and reductions, we also have condensation and hydrolysis reactions. Condensation reactions in organic chemistry is when you take two molecules and they result in making one molecule. And at times during this process, water is released. So you can see in letter A that this is showing how two alcohols come together, they form an ether and then a water molecule is released. In the case of hydrolysis, hydrolysis means that you're going to, quote unquote, cut a molecule with water. So in this case, water is going to be specifically in the reactants. And what we observe overall is that in these molecules, those atoms in water will be incorporated in the functional groups that we see as a result. So if we observe closely the molecules given, if here we have an ether and we try to cut it with water, we're going to see that one portion of the molecule got the OH in the water, the other portion of the molecule got the H in the water, and we can see the resulting alcohols present there. Now, when it comes to this concept in organic chemistry, it is important that you guys are able to recognize if you are given organic reactions that you have a condensation reaction, a hydrolysis reaction, an oxidation reaction, or a reduction reaction. So let's observe the following examples, and based on the functional groups given, we are going to determine if these reactions are going to be condensation, hydrolysis, oxidation, or reduction. Let's look at letters A through C. On letter A, we have, in terms of the carboxylic acids, or in terms of the functional groups, a carboxylic acid and an alcohol. We see that here we have two functional groups coming together to make an ester. So this type of reaction is called the condensation reaction. Specifically, this type of condensation reaction is called an esterification. Let's move to the next one. In the next reaction, we start with an amide. This amide is going to be reacting with water. And as a result, we can observe that the OH in the water is now connected to a C double bond O. And then the nitrogen that was in the amide received the hydrogen. So this is an example of a hydrolysis reaction. This is the hydrolysis of an amide. And when you hydrolyze an amide, you always make a carboxylic acid and an amine. Let's move on to the next reaction. We see that we have an alcohol, and then we see that the product is an aldehyde. And previously, we determined that when we have alcohols forming aldehyde, that is called an oxidation reaction. Let's move to letter D. On letter D, we start with a ketone. that ketone forms a secondary alcohol. You know that it is secondary because the carbon that is bonded to the OH is bonded to one carbon chain, two carbon chains. So this is called a reduction reaction. Lastly, when we look at the last pair of molecules, here we have a carboxylic acid and an amine fusing together to make an amide. And even though it's not written, I'm going to write it in. Water is produced in the process. So when we have this type of reaction, and I know that water is produced in the process because you see this minus OH. This minus OH refers to the OH, this minus water represents the water that is formed. So what this is representing is that here there is water lost. It's specifically because the carboxylic acid loses an OH, and then the amine loses a hydrogen. And what this results is in a reaction that is also called a condensation reaction. Specifically, this one is going to be called amidation because we form an amide. So remember, for the organic molecules that you guys are, or the organic reactions that you guys are responsible for in terms of condensation, hydrolysis, oxidation, and reduction, the main key is that you know how to identify the functional groups. Make sure that you practice. The last topic that we're going to talk about when it comes to this chapter it's not chapter 11, it's chapter 5. Is the idea of addition reactions to alkenes in organic chemistry. When it comes to addition reactions, you guys are only concerned with two different types of addition reactions. The first one is called hydrogenation. And when it comes to hydrogenation, we're adding hydrogen to an alkene. So that's why we form an alkane. And the other one is hydration. In a hydration reaction, we're adding the atoms in water to make an alcohol, okay? So let's understand that if we have a hydrogenation addition reactions, what happens overall is that the carbons that are either double bonded or triple bonded, they are going to receive the incoming hydrogens. That's why it results in the formation of an alkane. Understand that arenes cannot be hydrogenated only under very extreme conditions. So for the purposes of this class, if you have an arene, that cannot be hydrogenated. The hydrogenation reactions actually need a catalyst. And that catalyst could be a choice of either platinum or nickel or palladium. And remember that these catalysts are used specifically to speed the rate of the reaction. When it comes to hydration, hydration is a reaction that is only for alkenes. And in this hydration reaction, the carbons that are connected by the double bond, what happens overall is that they break, and we're going to add the atoms of water in the form of H and OH to produce a product. For hydration reactions, we also need a catalyst, but our catalyst is going to be H2SO4. Let's actually do some practice problems so we can learn how to predict the products in these reactions. In order to do this, I'm going to go over specifically problems 2, 3, and 4. So for problem 2, how do I know if I'm going to do a hydrogenation or a hydration? Problem 2, you can see that we have H2 as our reagent. So that means that this is going to be a hydrogenation reaction. In number 3, I see that I have water and acid. This can also look like H2O, H2SO4. They're going to mean the same thing. And whenever you see H plus H2O, or you see H2O and H2SO4, this means that this is a hydration reaction. Take a moment and decide, is number 4 a hydration reaction or a hydrogenation reaction? But I'm going to first proceed to determine what are the products for number 2 and number 3. On number 2, since I know that this is a hydrogenation reaction, I'm going to add hydrogens to the carbons that are double bonded, and I'm going to take away the double bond. That's why it's called addition. The double bond breaks, and the atoms that used to be double bonded, now they're going to receive an atom. In the case of hydrogenation, they're going to receive hydrogen. So for the product prediction for reaction 2, what I need to do is write the reactant given, to predict the product. I'm going to erase the double bond, and the carbons that used to be double bonded, each of them are going to receive a hydrogen, and that's how I predict the product. If I use my highlighter tool, this is the carbons in the double bond. This is the carbons in the double bond. I erase the double bond, and each carbon receives hydrogen. Let's now go over number 3. In number 3, I already determined that this is a hydration reaction. In a hydration reaction, one carbon in the double bond is going to receive a hydrogen. One carbon atom is going to receive the OH. How do I determine that, which carbon receives the H and which one receives the OH? Well, we're going to look closely at the molecule given. These are the carbon atoms in the double bond. We can see that if we label these as carbon A and carbon B, carbon A is directly connected to one hydrogen. Carbon B does not have any hydrogens directly attached to it. Since carbon A has it has a direct attachment to a hydrogen atom, when I erase the double bond, that carbon receives the hydrogen. And carbon B is going to receive the OH. So this is how you decide who receives the hydrogen in a hydration reaction. Whoever is connected to the largest number of hydrogen atoms, directly connected, that's going to receive the incoming hydrogen, and then the other atom is going to receive the OH. So when I decide what is going to be the structure of the product of this reaction, I'm going to take my starting material. I'm going to redraw it. Let me make some adjustments because of what copied. Overall, when I'm predicting the product of a hydration reaction, I'm going to erase the double bond. And because carbon A is directly attached to one hydrogen, that means that it has more hydrogens than carbon B, because carbon B is not connected directly to hydrogens. As you can see, carbon B is connected to carbon and carbon. Those carbons have hydrogens, but carbon B directly doesn't have hydrogens to itself. So what that means is that in this hydration reaction, this receives the hydrogen, this receives the incoming OH. Based on this information, decide what is going to be the product for number 4.